Welcome to the Are You GCSE Physics Ready playlist. This playlist is packed with example questions and guided solutions for every GCSE Physics topic. So it's the perfect tool to help you test your understanding. If you feel like you might need a quick review of this topic before having a go at the questions, or you would just like the ideal revision companion for these videos, then do make sure to download my free GCSE Physics revision notes, linked in the description below. If you're ready, let's dive in. Okay, so our first question on the left is looking at this notation, and it is how many protons, neutrons, and electrons are there in the following atom? So, in order to answer how many protons we are looking at the bottom number, which is called our atomic number, but tells us how many protons in the nucleus of this boron atom, so that is 5. Then to find the number of neutrons, we need to look at that top number 12, which was our mass number. But remember, that's the total number of neutrons plus the total number of protons. So if I want the total number of neutrons, I need to do 12 minus the number of protons, 5, gives me 7 neutrons. And then since this is an atom and not an ion, I can say that it should be neutral, and therefore the number of protons should match the number of electrons, so that should be 5 electrons. Okay, next question, how do electrons and neutrons compare to each other? How many electrons would be needed for the same mass as a neutron? Okay, so two things that you need to compare and contrast. First is charge. So electrons are negatively charged, and we say they have a relative charge of -1, whereas neutrons are neutral, so their charge is 0. And then the other thing you need to talk about are their relative masses. Electrons have a much smaller mass than neutrons. How much smaller? Well, you would need 2,000 electrons to have the mass of the same as 1 neutron. Atoms and isotopes now, so carbon-12 has a mass number of 12. It has 6 protons. What is the atomic number of carbon-12? Okay, so firstly, atomic number is my number of protons, so that must just be 6. And what is the number of neutrons? Well, again, take my mass number 12 minus the number of protons. 12 minus 6 gives me 6 neutrons. Is carbon-14 an isotope of carbon? So yes, it is, because that 14 is my mass number, but it is still carbon, which tells me that it must have the same number of protons, 6, but since its mass number is 14, it must have 8 neutrons, which means that it must be an isotope, same number of protons, but different number of neutrons as carbon-12. And what about an atom with 5 protons and 7 neutrons? No, that's not an isotope, because whilst it does have a different number of neutrons, it also has a different number of protons, which makes it a different element altogether. Okay, atoms and ions. So carbon-12 has 6 protons. How many electrons does a carbon atom have? Well, same, because atoms are neutrally charged, so that should be 6 electrons. And how about an ion of carbon with a charge +4? So don't get confused here. +4 means that you have lost 4 electrons. You can think about the electrons as your worries, if you like, to help you. So when you lose them, you become more positive. So if I lose them, I get a charge of +4. And how about an ion? Oh, sorry. So that means how many electrons would I have? Well, I had 6 and I lost 4, so I'm left with 2 electrons. And an ion of carbon with a charge -3. So now you become more negative. You must have gained electrons. So you've gained 3 electrons. If you started off with 6, you must now have 9 electrons in total. Okay, next question is describing how an ion is formed. So you can either have positive ions or negative ions, and if you have a positive ions, you have removed electrons, so it becomes positively charged, and if you have a negative ion, you have gained electrons, so it becomes negatively charged. Next question, an electron moves up an energy level by absorbing a wave,
Another electron moves up 2 energy levels by absorbing a wave. What can you say about the wave absorbed by the second electron? So, the larger the frequency of your wave, the larger its energy is to jump larger energy gaps. So my second electron that managed to move up 2 whole energy levels needed more energy to do it, so it must have had a higher frequency wave that it was absorbing in order to get that energy. And what would happen if the electron moved back down the energy levels? When the electrons move down energy levels, they actually lose energy. And where does that energy go? It gets released as a wave, so released as electromagnetic radiation or a wave. Okay, time to talk about the models of the atom. So first down here we have explain what the plum part of the plum pudding is and what about the pudding part. So the plums are the negatively charged electrons that are distributed evenly throughout this pudding, and the pudding is that ball of positive charge that the electrons are distributed throughout. Okay, why do only very few alpha particles get reflected back? So in order for an alpha particle to be reflected back from the gold atom, it must be almost in line with the nucleus so that it can feel the strong repulsion that would be required for it to be sent back in the same direction. And in brackets there, since the nucleus is very small compared to the size of the atom, that's why it only happens to very few alpha particles, because very few alpha particles will happen to be aligned with the gold atom nucleus as they're fired towards this gold foil. What are 3 conclusions of the Rutherford experiment, and link them to the results? So your 3 conclusions coming from the results are as follows. 1. Most of your alpha particles go straight through the gold foil undeflected, and that's because the majority of your gold atom is actually empty space. Second, some are deflected through an angle. That must mean, since your alpha particles are positively charged, they've come near the positively charged nucleus and they are being repelled by that nucleus. So the conclusion is you have a positively charged nucleus. And finally, very few are reflected back. And the fact that there's very few reflected straight back, and those were the ones that would be in line with the nucleus, tells me that nucleus must be very small and so very dense. Your mass and your charge is concentrated in the nucleus of your atom. Okay, finally, this little question on the bottom, how did Bohr then extend this model of the atom further? And the answer to this is Bohr talks about electrons moving or orbiting at set distances from the nucleus. So the Rutherford model doesn't really mention where the electrons are, and Bohr says they're at set distances from the nucleus and they are orbiting those set distances from the nucleus.
Just before we go into the tips and tricks section, if you do want some extra advice to getting that grade 9 for your GCSE, then why not download my free 20-minute exam success guide? Just click on the link in the description below. I'm going to give away all of my best advice and secrets, and completely for free, so why not?
Okay, finally some tips and tricks for this section. So electrons versus protons, they are the same if you are talking about an atom, i.e. there's the same number of them because it is neutral, so just remember that. +3 and losing electrons, yeah, don't get this the wrong way round. If you become more positive, like your charge becomes +3, that is because you have lost electrons. That's why it's useful to think of your electrons as your worries. You gain them, you become negative, you lose them, you become positive. Mass number and number of neutrons, yeah, just remember your mass number minus your atomic number and number of protons gives you the number of neutrons. And Rutherford structuring answer. If you are asked a question about the Rutherford scattering experiment, you should learn the 3 results and you should learn which conclusion you can draw from each of those results, just like the example that we've just done. and basically learn that as something that you could regurgitate in your exam if you needed to.